So now we going to move to another use of the maser. So the first maser that was demonstrated was possible, that it was shown that it was possible to coherently amplify microwave using excited atoms, but the gain and the power of the first masers were low. So only in a matter of a few years, solid-state traveling wave masers were developed, and they provided a higher gain and very low noise. So they were used as preamplifiers in the receiving antennas for the first satellite communications, such as ECHO and Telstar. They also play an important role in the discovery of the cosmic microwave background radiation, which provided the proof to the theory of the Big Bang. So Arno Penzias will discuss this in his presentation.
It's a great honor, a bittersweet situation, but I'm very glad to be here and to be able to contribute to some of the bit to Jim's memory. So moving right along, this is these two kids there is the way we looked, whatever that is, 70 years ago, some such number. It's hard to subtract those kind of numbers. I can't do it on the fingers of one hand, so we just let it go. But anyway, this maser allowed us to do stuff which would otherwise have gone or would have taken longer, or because people, the main thing was that actually a lot of people knew that there was something wrong with the antenna. Several different groups felt, it was a little bit noisy, and one couldn't figure out why the whole system, didn't have a noise temperature of what it did, but had a couple of, maybe 3 degrees more. And so there were two people, and one was the antenna guy, and the other was the receiver guy. And so they divided it, and one of them got 1 degree, said he was off by 1 degree, and the other guy was off by 2 degrees. I didn't know which way it worked, but the number added up to 3. When we moved ahead with it, what I want to say some things. Masers were there for the first satellite communications. And as such, they were you can see this is satellite communication because that particular dish there was a transmitter which broadcast off the ECHO satellite, a balloon which actually moved across the sky and could be seen and even played a role in Victor Borge's outdoor, those of you who remember who he was, outdoor concerts, because he would talk and then he'd say, hey, watch ECHO go across. It was kind of an interesting thing. But there was this huge balloon. The satellite could be transmitted from JPL, Jet Propulsion Labs, and then on this end, we wanted to make the antenna as sensitive as possible. And this horn antenna, we knew, was looking exactly at the sky, and we could look for it to do a number of things. You've seen this slide before. The maser was done in a number of ways, but the important thing was that when Jim and Professor Towns, I can now say Professor Towns, but it took me a long time without stammering. I'm very much in awe of this gentleman. But what happened was there they had the first amplifier, and then they were able to build a traveling wave amplifier, which was hugely important in that it provided a very stable, very broad bandwidth, which was not otherwise possible. And so when we looked at that, we looked at this Ruby Maser amplifier. It seemed so good that what we wanted to do was see if we could measure the temperature of the sky. And the reason we wanted to do that was we wanted to measure what the deep sky looked like, and that's hard to do because we are inside the Milky Way. And so we wanted something very stable, and that we thought that as you move from the middle of the Milky Way out and out, it would finally go to 0. And we had this, and it turned out not to go to 0. There was this nasty 3 degrees, which we had to deal with. And so this was the detection system. We had a horn antenna, And what we decided to do was the one thing we wanted to know was, where is this extra noise coming from? And so I went into AT&T's wallet and bought a flask, which, in order to fill it, it was about this wide and it's almost as big as I was, and we filled it from a tank of 5 imperial gallons of liquid helium. And this is one of the things that were just not counted in the books of the time, and so I could just get this by signing for it. And so, therefore, we had this very low noise amplifier, this very low noise source, and this beautifully stable, sensitive amplifier that could look at the signal as it went across the scale. And we looked at that signal. What happened? We looked from the horn antenna, we point up. You see how stable that thing is? In between is a noise standard. But as you know, you can see where it goes. And we went to, the point was, the antenna turned out to be warmer than this cold lobe, this flask of liquid helium. And that 3 degrees was there, and we couldn't get rid of it. We didn't know what to do. And it turned out, of course, that it was the echo of creation. And we wouldn't have found it had it not been for the facility, the support, the teaching, and also the atmosphere provided by my fellow students at Columbia University. So I'm very happy to be here to thank Jim's memory, Professor Towns, of course, as well. But this is where we got to. And, you know, somebody once, some other person once said, "I have seen far because I have stood on the shoulders of giants." Thank you.